Welcome to a new test and teardown video. This time it's a new Spectrum Analyzer. Well, new and new, maybe, but it's from Marconi Instruments. And this model is called TF2370. Its maximum frequency is 110 megahertz, but it will go all the way down to 30 hertz. Yeah, hertz. That is low. So I can't wait to go and play with this one. It consists of two different units, and you can disassemble them quite easily. We got some interconnects on the back, two multi connectors. And the top unit here is the display unit that is 19 kilos. And the bottom part here is the RF section. And that one is 18.6 kilos. A total of 37.6 kilos. So they actually shared the weight distribution here really good. The CRT is a standard magnetic deflection screen, and it's updated or refreshed 70 hertz. So it is sampling in 8 bits, and the width display here is 512 sections. So that is actually 512 bytes of display memory. I actually know this one works or powers up and shows some stuff, because it was powered up when I got it at a local flea market some time ago, but now finally it is here on my table to play with. So I look forward for some happy days of Spectrum Analyzer play. So let's just mains entry on, and I think it's right here, right? And it's using 120 watts. Yeah, I can hear the transformer is humming. Intensity, maybe that is. Yes. Oh, so this is how it's emptying the memory at power up. Okay, this potentiometer here needs a little bit of exercise. And then it continues. How beautiful is that? Why are we having those funny grids? I don't understand that. So it's running some power up stuff, I suppose. I never powered this up myself before, so I don't know exactly what is to expect, really. Yeah, okay, so we got some stuff here. I'm not super lucky about this. What do I need to do here? Oh dear. What is this damn thing doing? So a little look from the back. We got two very big interconnects between the RF section and the display section. The display section also contains a very beefy power supply. Look at all that. And of course, mains entry and voltage selector. And it is set for 220. I think I will go and set it for 230, because this is what we got. And I also think that the original assembly or like mounting system, this clickety-click, was probably defect or something like that, because look what I got here. Just a piece of aluminium, and then you use two screws. Of course that will work perfectly fine. And it's the same here at the other side. And this don't really look original. That looks original. So that is to assemble the two halves. So I've been playing a little bit with this unit, and I think I figured out how to use it and what it is all about. So at the moment I input 23 megahertz, and we should be able to see something in a few seconds. There is of course a warm-up delay, and of course there is some kind of drift because I am super zoomed in on my 23, and that will go into the middle. Okay, I can see the camera here is doing a lot of different. See? At the moment I really don't see this dark here, but the camera sees it. So this is my 23 megahertz, and they're gonna go into the middle when it's done warming up. I'm also super zoomed in, of course, as you can see here. I am in, what is that? That is 50 kilohertz per division. And it is, of course, not in phase lock or anything like that. It is free running the oscillators. So I'm not touching anything, and I'm using the normal filled-up bandwidth. Oh yeah, while we are waiting for the warm-up, we can look a little bit here on the display. I am now in high definition. I display A, and I am storing in A. So I don't know if you can see the difference. So that will be the pixel sizes. So now we'll click the high definition. See? Now the pixels gets even smaller, right? Okay, it moves the screen a little bit. So we got different intensity. So this is a global intensity, and if I crank this up, you're going to see some markers. I'm sorry about this flickering here, but you will see some markers. That's of course the frequencies and the dBs, whatever. It depends on what kind of stuff you're doing. So I am doing 10 dB per division. That is done here. And that will be my input level. So I got 0 dB is, it says here, 0 dBm, that is the top of the screen. And also if I look at my signal generator, so that is also 0 dBm at only 23 megahertz. So there's not a lot of loss in the cable here and all that. So I think that will be that line here. That is 0 dB, and it also touches that line. So this is my general brightness, and I can of course crank that down so you can't see the grids. See, if you crank it all the way down here, you don't see any grids at all. But if you add a little bit, so you just barely see them, that is fine, right? Then we have the graticule. So that's the grids. You can move them. Oh, let me crank them up here. So you can move them like that, and then it becomes uncalibrated. Or you can shift them. You can also change the intensity of A and B. We're not looking at B at the moment, but you got individual intensity. That is a little bit funny, right? And so if I'm at A, at the display A or display B, depending on if I store B and display B, see, then I got, so let's make B very, very dim. So store A, go to display A, and then I can stop storing. See? And then it gets frozen. So that is a frozen because I am displaying A, but I'm storing in B, or I can go and store in A and stop storing in A. So we got some storage features. We also got some peak memory. So it will add to the display. See, if I enable peak, see, then my noise floor just gets higher and higher, and it will just do that forever. So there's actually also another funny feature here. That is with my center frequency is left, or I can add a bright line, And I can add the bright line in single mode, for example. And so this is my frequency counter. That is this display here. That is displaying now my bright line. And that is the bright line. So if I move my bright line position, see, my display here is also changing. And since I am inputting 23 megahertz, see, if you put it in the middle of my readout, it also reads the frequency. So that is quite nice. The bright line readout feature don't work when it's running. You need to be stopped or in single like that, right? Or in manual mode. So in manual mode you can actually paint. See? You use the line to actually create the sweep. Well, I don't understand exactly how that works. Maybe that works in a peak mode or something like that. I don't know. Not really. But it's really a nice spectrum analyzer, and it's super easy to use. Once you figure out that you select either megahertz or kilohertz. Okay, that is a good place to start, right? And then we're going kilohertz, and then it's all kilohertz here. You can of course also do full span megahertz and then go 10 megahertz per division. So here we go. This is a full, and then I make my, of course I want to make my filter real wide. And here is a full sweep, and my left, where is it? Here it is. See, here is my pulse. This should of course be okay. Let's try and turn off the input. Yeah, see, this is my input. That one, right? So the most powerful one is my 23 megahertz. This is of course 0 hertz, and that one you want to go all the way to the left. My center frequency is adjustable here as well. So if I put my 23 in the center, because I am at 10 megahertz per division, see, this is 0, right? Yeah, this is how it gotta be, right? I can of course move my 0 all the way here. So that is my 23, right? And then it's showing the entire 110 megahertz. Really cute. I think it's time to look a little bit inside. So I'm now inside the RF section. I only took off the top lid and removed a couple of screws each side here. I see some hinges here, so what we can do is just flip it up. And as you see here, we can also access both sides of each module. It is really that impressive. We can take it all the way. Oh, nope. We should not do that. I can hear the wires like, ooh. So we should probably hold it with something. Right now it's going to be my hand. And I can see the modules, they are sealed like that. So nobody was in here, and inside this module here, yes, somebody was maybe inside, or the seal was broken. Here it's definitely a broken seal, and that one is not broken. So yeah, we need some manuals here to go and look what this can do, but it is of course working, so I don't need to go and hunt down stuff. But what I wanted to do is just open one of the modules, one or two maybe, and just look for the design quality and how is this really built? What kind of level of fantastic things is in here, right? But I mean, this is so far pretty amazing. I must say, I kind of like that. I would have been even more happy if we had a little hold this kind of thing in here, but there's probably a trick to this. I just haven't figured it out yet. Is this the right way to do it? I don't know, but I think it looks kind of nice. That is a good solution. It's good and stable to use the lid. All right, let's have a look inside this one, because we got the 10 megahertz standard frequency and the amplitude of that. So that will probably be something that we can recognize. So let's have a little look inside one of the modules. Oh, by the way, we got 2 of these modules at the top with hinged, and then we got 2 down below here, but I don't know if that is easy to see, but we got actually 2 more, and you access those from the bottom side. Just remove the bottom lid, and in here we find some op amps, line cleaner. What exactly is that doing? And that is, of course, the 10 megahertz reference oscillator, and the frequency alignment for that. We got a 80 megahertz and a 40 megahertz oscillator in here, and we got local drive 4 megahertz 500 kilohertz, and that one is a tracking generator output, right? And see, we got some modifications here. So that coax here is disconnected, and this output is removed or bypassed by a little attenuator and a capacitor, because a previous owner wanted to get access to probably a wider frequency band output instead of going through that one. So that's quite neat. All the different boxes there, of course, yeah, completely different depending on what kind of stuff there is in here. So now we're looking inside one of the filter sections, and it is just really, really beautiful. Of course, it's not super compact made, especially not when we think about today's standards, where everything is designed to be as insanely compact as possible, because yeah, we just want small products, small, cheap, lightweight, and all that kind of stuff. But look at that. Nothing here is small or compact in any kind of way. You can easily access every little thing and measure around here, and it's just fantastic with all the different things. Of course, this is a very low frequency. This is the 500 hertz filter, and this is a 5 kilohertz. And you see that all the different inductors there, of course, wire wound to some very specific specifications, and handwritten here exactly what happened here and all the values and such, right? But of course today you will just take a few SMD components and then Bob's your uncle, right? This is nice. So for good thermal design, look at the standoffs here, and that is the lid that goes on top of that, right? So that means you're not able to cover up the top because of those, and they're like 3 centimeters tall, right? And that is really, really good for thermal, that you get a lot of fresh air in here. So this is the CRT section, and I don't know if you recognized this by looking at the 7 segments, the frequency counter, but I did, and as you can see here, it's a neon filled 7 segment display, and they are running on high voltages. And this is just a way to create a very good bright high contrast display, and they last really, really long. I totally love them. So that is great. Why is this one loose? Oh, this is just glue. Okay, I'll have to fix that. There's not a lot to say about the CRT section other than that it is really, really well built. Everywhere I look, it's just really, really nicely built. CRT here, shield, CRT stuff. That looks definitely like high voltage with the inductors and all that kind of stuff. That's probably horizontal, and as you can see here, the high voltage transformer as well as that, and that's probably the vertical or the horizontal, obviously. Yeah, that's the other deflection, right? And we also got some high voltage stuff in here. That's just the triple, I guess, because you see the red anode wire is just in here. So that is a very big tripler. And in here you'll have the adjustments for brightness, focus, and such things. And like I said earlier, the CRT is a magnetic deflected type of CRT, as we can see here. I can't really get this all the way off, can I? No, doesn't matter either. If it's not going, it's not going. All the capacitors, very big mains transformer, and it is just super packed with plug-in boards into a there's probably a board. Yes, there is definitely a big board down there as well. I don't want to pull out all of these and show them anyway, because it's not super relevant. It's just some gates and op amps and such. Not super interesting. But I wanted to see if I can find the display memory, and also I wanted to see, yes, look at that one. Well, that's pretty neat. That is a very big IC4. Yeah, let's pull that one and have a look. So that was quite easy to pull up. And see, there's a static discharge warning here on that board. And this one is MH0009CG. So that is a memory clock power driver, a push-pull kind of a clock driver, really. And it will do 30 volts and 500 milliamps. That's actually quite amazing. Is that really needed? I'm still looking for the memory though. Is there a number here? So what if I pull up AE2A? AE2A. So I can't do this wrong, can I? All the modules here are really, really built nice. So this is a 2-layer mixed analog digital kind of board, and look at the way that it is manufactured. Super, super nice and beautiful. It's still shiny and all that. And by the way, look at the plated throughs. There are those metal stamp in kind of things. So that means it is not done by plated through technology, but it is a 2-layer board, drilled, stamped, and then soldered and tinned, and then all the components and all that kind of stuff. So that's the kind of manufacturing process. This also means it's a little bit difficult to go in and out of ICs, as you can see here. So they need to have a via made before the hole. That's also a little bit weird. They could have soldered this on both sides of the IC, right? Yeah. That is 2 holes really, really close there. But that is 1976 technology. I'm pulling a few more boards out just to have a little look here. So that is a board full of counters and stuff. And again, How many decoupling capacitors do you see here on the VCC rails? It's probably only that one. And is that really? Yeah, that's more or less maybe on the rail. I kind of don't know. And that one is full of, what is that? Just gates and counters and such, right? Yeah, more or less. And only one capacitor on that whole board. That's amazing. One resistor and one capacitor. No. Oh, four resistors, and that is all there is to it. Oh, this is nice. Can you imagine the kind of paper cat they used to design these boards back in '76? This is just transparent plastic and oh man, rub the tracks until you're happy. Oh yeah, by the way, I wanted to show you this. Down here between the connectors, look at all the wires that's going back and forward in the unit from the front section to the back and all that. So that's definitely some more stuff down here. I really want to take away the bottom cover and let's have a little inspection. The bottom of the CRT section, that is just absolutely beautifully made, really. Of course it took a few hours to solder all those wires into all those connectors here, right? So that's the interconnect for the RF section. And we also got a few little coax cables coming in and out here, right? And look at all the plug-in here. It's carefully done like that. So some of the modules, they only connect on one side, and this one connects on both sides, see? Some signals are on some sides. And here we got both of the sides, and we got some, yeah, it's absolutely amazing. Well built, well constructed. And it looks like we can take away the entire power supply by just some few screws here, and then this end part of the unit can be taken away, and that is what we can see here. Oh yeah, by the way, I forgot to say this. There is a connector here for a XY recorder, so analog output of the screen. That is amazing. And all this is done in Logix. There isn't any CPU, there is no software in this unit.